Recording in progress.
Alright guys, so we just finished the section regarding the intermediate value theorem. So what did you guys think was the easiest part about this?
For me, I think it was just the understanding of like the over the x-axis type thing. So like every time we saw a circle over the x-axis, we knew that there'd be a root. For me, that was like the easiest part.
Yeah, I'd have to agree with him. Deciphering whether something's a root or not was pretty easy. It got a little bit dicey when it came down to the size and the, I don't want to say trickery, but the graphs that don't look how you anticipate. But I
Right.
feel like that just kind of exemplifies that a graph can do whatever, and just because you see what's on the outside doesn't mean that it is a root. So you definitely need to take the whole graph into consideration.
Right.
Yeah, I was thinking something along the same lines. Like before we were introduced to the intermediate value theorem, our instinct was to see where the circle initially was on the x-axis, and then see at that circle if the function goes from some point positive or negative in the circle to its opposite side being. So, for example, if it was negative at first, then later positive. If it was positive, then later negative at that circle. If the circle is obviously located on the x-axis, then usually we assume that's where a root is located.
Yeah.
Right.
So, with that being said, is there anything that we found hard about this?
I would say just making that jump from physical application, or from on paper looking at the theorem to physical application to something happening in real life. That jump was a little bit difficult, but once we kind of got through the process, it started to make a lot more sense. But just really just the application for me.
Okay.
Yeah, I'd agree. Honestly, the application was a little different for me. And I hate questions where I have to like just like write things down and fully explain them. But as soon as like we like read over it and actually understood what IVT meant, it was much easier to answer.
Yeah, I also really find the like that real world app, even though sometimes it could be a little tedious, a little complicated, I do find the like real world aspect really interesting.
Mm.
So like this looks something like, for example, when we were doing the lab, the like circles, the idea of it going from positive to negative or negative to positive, and then being like, oh, there's a root there.
Right.
We see something like that, and we're like, oh, this is such a simple concept. This is that, but then once we like try and apply it to like real world stuff, like for example the CO2 model that was shown to us that scientists use, and we could see it kind of looks like a stock market where the values are going up and
Right.
down,
Right.
but then like over time you see it slowly going up, and then if you look at it from like let's say a bigger scale, it looks like it's just slowly going up. Whereas if you look at like the little pieces, it's just going up and down, up and down, up and down, up and down. And we could see how like the IVT can really come there, because like let's say, oh, between this time period and this time period, was there any specific point where the average global temperature, the average CO2 emissions was at a specific point?
Right. If it was passed
On
through.
the So I think that right there kind of leads us on into our next like question is what else do you guys like wonder or like think about this IVT concept in general?
Honestly, for me, I think like what I wonder about it is probably like how you were saying how they applied it to like carbon, like the carbon dioxide like diagram that we saw. Like how we could use the IVT for like other stuff, such as the stock market and how it goes up and down throughout time, and whether or not it's passed through its point where it used to be. And I think like even like if you use stock apps, like I've used some stock apps, you'll see like if it's past its original point, it'll say like plus a percent, like it'll show you if it's gone through that point. So to me, that's like the thing I'm interested about.
I'd have to agree with you on that. I think just the application and, gives you a little bit of historical data. You can look back at stuff and kind of calculate and see, are we above what's normal? Are we below what's normal? Which could be good or bad in different circumstances. But I think the application and the different opportunities that we could use IVF or IVT would be really good.
Yeah.
Yeah, you guys, I think, like, touched on this idea, but, like, didn't directly say it, but, like, especially for, like, the stock market, CO2, all these other stuff that involve continuous data, I wonder if then, like, that behavior, so, like, let's say, the IVT is used for a specific interval, another interval, another interval, another interval. I wonder if, like, that could then be used to predict maybe future intervals.
Right.
Be like, okay, we expect it to look like this in the future for so for the stock market. We've reached a point where it's like this, and these intervals have shown us like it behaves like this. So that means in the future we expect this is how it's going to behave. Same with CO2 emissions. This is what we've seen with intervals in, like, let's say the past. So in the future we expect these intervals to behave like this.
Right.
So that's a topic that I'm really interested in, if like the IVT could be used for stuff like that.
Yeah.
For sure.
So that should do.
Yeah.
I really enjoyed this.
Me too.
Yes.
All right. See you guys later.